In this installment of the C-Suite Spotlight, I'm thrilled to welcome Wenkai Wu, CEO of Reed Semiconductor. Wenkai is a distinguished electrical engineer who holds not just one, but two doctorate degrees and has earned more than 10 patents in the field of power electronics. His career journey started at International Rectifier, where he was an applications and systems engineering leader, developing critical power supplies for server CPUs. He went on to Texas Instruments and spent over 11 years developing power systems for compute and memory products, and he rose to become the business unit leader for TI's multi-phase power division. In 2019, Wenkai saw the opportunity to serve the growing need for more efficient power ICs in the data center and HPC markets. So he reunited with past colleagues to found Reed Semiconductor. Today, he leads the organization and has built a strong reputation for delivering innovative and reliable power solutions for various applications. Wenkai, it's a privilege to have you, and we're all eager to hear your perspectives on how power delivery and power management are rapidly changing. So thank you for being here, and let's get into it.
Thank you, Jason. So very nice talk to you as well. Thank you.
Yep, great. Thank you for being here too. So, Wenkai, I love starting out with this question for executives with technical backgrounds because it raises interesting stories. When did you first know that you wanted to be an engineer?
So to be honest, probably from graduate school. So since I stepped into this power electronics area, so I start to feel, this will be my life.
That's great. Yeah, and like you said, not an uncommon not an uncommon process there. So would you walk us through your career journey so far, and like highlight any pivotal decisions or relationships that ultimately led to you becoming CEO of Reed Semiconductor?
Thank you. Yeah, sure. I think I start my basically power, semiconductor career from IR. Later was acquired by Infineon. I think by that time I was application engineer for VR11, basically like Intel processor power, and also the multi-phase to power the processors, to power the CPU all over the world. That's kind of by that time, Intel processor is like dominate, right, the processor market, and I feel it's so cool, So, you know, um, the computing, right? Basically, it's a brain for the industry to do all the calculations, and we provide the power to make it work. So that's the reason I think this is something, um, will be the future. So, and then I start to feel some challenges, and I have seen the trend, right? And the computing capability will grow, and since there actually for past 20 years, I stay in this area. So that's my first job in IR, and like 2007 timeframe, I joined TI and started the team with power management products to support vCore and data center server system. And by that time frame, actually, because of the company scale, right, I lead the team to contribute to the industry, to basically brought up the concept of the smart power stage, integrate like a driver intelligence with, power MOSFET into the one smart power stage. And actually, right now, that product and concept has been used by whole industry. And that's actually, I feel very proud, right? You can, by innovation, you can impact and change the industry, And in 2013 timeframe, um, I actually think about like power for DDR5. And actually, we started the journey even from DDR4, but by that time frame, we ran out of time. But in 2000, DDR5 start to talk about in the JDEC. Actually, I went to the JDEC with a proposal and convinced JDEC, right, is to develop to change the power architecture, develop dedicated PMIC for the DDR5. It's right to go. And sooner or later, sooner better than later. So, and convince the team and leverage all the resource from previous company TI. And I really appreciated the opportunity, right, to have a lot of opportunity to impact the industry. I think right now, this like DDR5, the power delivery architecture totally changed, right? It's from the motherboard to the PMIC, to the DDR, the wire on the DIMM. So from these two like big change in the industry, I start to realize, by innovation, by doing the good thing and great thing for the industry, you feel real proud of yourself, and by engineering, right? With the engineering innovation, by partnership, you can really contribute to the industry. This actually sponsor me and inspire me do something new in the resemi as well. So I think that's it's a very short story, but hopefully this is you can tell this is the idea why we want to start the resemi. Even it's very lots of well-established company play in this area, but we truly believe with some by innovation and partnership, we can contribute, a lot and impact the industry by innovation, by bringing, the more reliable, efficient, and high density solution, especially for today's power hungry like computing, AI and data center systems.
Yeah, and to kind of take that a step further, for those who may not be as familiar with Reed Semiconductor, and you started kind of talking about it just a little bit there, but can you give us an overview of what the company does and really what you're building?
So the read semi, right, actually, like the name stand, for reliability, R, and efficiency, eco-friendly, and density. It's very focused on the power management for AI and data centers. So we have seen a lot of challenges, with we have seen like power density and current level, right? Generation to generation is like exponentially grow with the transistor in the processor, doubled every single year, right? And computing capability double, tripled it. So the current requirement is goes up like it will be very challenging for the whole industry. I think with so many years experience with a talented team, we think we can help to address these kind of challenges for the industry.
No, that's great. That's great. You're doing a good job and kind of beating me in my questions because you already kind of started to answer this one. But coming over the next kind of 1 to 2 years, like in what sectors or applications do you see demand growing the most for power management and power delivery ICs?
So I think right now the AI is very hot, right? AI, data center, even automotive drive. So you can see, right, even automotive drive need a huge computing power as well. So with that being said, I can see AI continue, data center and automotive drive. That will be the major focused area for us to contribute, and some challenges we can work with the industry to address these kind of challenges.
There's ongoing debate about the power benefits of substrates like gallium nitride and silicon carbide compared to silicon. What's your position on this debate?
Yeah, so I think I'm really glad, right? So like silicon carbide, gallium nitride, start to can improve the performance, but in my mind, I think Silicon, right, is pretty mature, and in terms of like cost and maturity, they have their own sweet spot. So like silicon carbide, address the high voltage, right, and gallium nitride, some high frequency in the mid voltage. This I think it definitely is a sweet spot. But for low voltage, high current applications, I think because of reliability and the performance and the maturity perspective, I think they still have their own sweet spot. So that's the reason right now our focus on AI and the processors. I believe silicon solution still have their own um, advantage, in the coming few years. And here, we have seen some breakthrough in either gallium nitride or silicon carbide in this area.
Okay, cool. Oh, great. Thanks for going through that too. Always curious to know that question. It's always a topic. When I was at APEC, everyone was talking about that as well. And you mentioned with AI processors. I mean, what makes power delivery for AI processors so darn challenging, and what could be done to kind of solve those challenging issues?
So you see right now the AI, right? So the processor already like beyond 1,000 ampere. Probably talk about the 2,000 ampere and beyond. So with that being said, the Ohm law right here, right? It's I square C, no, I square R. So the R is resistance. So with that being said, 1,000 ampere times the resistance between the power output to the processor will consume a lot of electricity, will generate a lot of heat. So in other words, the power loss and heat will put a lot of challenge in addition to the processor heat. So that's the reason lots of cooling technology emerge right now. It's become challenging as well. So fundamentally, if you can reduce the power loss or generated heat, there will be tremendously help the AI computing capability because right now the processors are already pretty hot, right? If you, uh, in addition to that power loss and heat, the power supply, the power delivery, loss, that's not only consume lots of electricity, but also generate lots of heat you need to deal with. With that being said, there is a saying in the industry, right? Every single watt, every 1 watt power loss, you need consume another 1 watt to cool it down. So that's actually present a huge challenge for whole industry. So I have seen a report said, in 2030, the electricity consumed by AI will be around 25% the overall US electricity. That's huge compared to today,
Wow.
like 3 to 4%, right? So that's the real thing we need to address from the all the all the engineering world, right? Especially in the power electronics world, for the power management industry, we have to work together to solve these kind of challenges.
Wow, no, that's absolutely fascinating. The industry, it has a lot ahead of them, but the market, the power IC market, has some very established giants, and is seeing more newcomers. What differentiates Reed Semiconductor, and how do you leverage that differentiation to stand out in an increasingly very crowded market?
Yeah, so that's a great question, right? So, yes, there are lots of respected and well-established companies in the industry, but we have seen, right, because of this power hungry and challenging for the processors, the low voltage and high current, and the trend never stop and will be exponentially, grow. So with that being said, traditional approach or traditional technology might not be the best answer. So that's the reason I think something, if you come out very robust, very high efficient, very high frequency to improve or in the density, that will be uh, better suitable for this AI and data center applications. So with that being said, we uh, you know, many years experience and connections and partnership, with this networking and friends and this like veteran in the industry, we can work together, can come out something that traditional technology couldn't solve or couldn't compete or couldn't come out some solution which is much better availability and efficiency. There will be I think all the industry is more than happy to see the solution, and we can find our home, and customers are right there, and the customer is waiting for the and looking for a solution with reliability, right, and efficiency and density. So one thing actually I want to highlight here, with the current goes up, beyond 1,000, 2,000, they have a lot of power component in the system or on the board or on AI card. So with that being said, you have like hundreds power components on the board. So the availability is not a traditional uh, standard anymore. So we need to like improve your availability probably 100 better times better. So otherwise, one of these 100 components fail, you kill the GPU, kill your CPU, kill your system. Nobody wants to see that happen. So with that being said, reliability will be the number one priority, like our name, right? Our company put the reliability as the number one priority on top of on top of the efficiency. So that's the reason we put the reliability and efficiency and density. This is the order for us. It's really focus and address the requirement for AI and data center power requirements.
Oh, it's great, and that kind of bleeds right into something that everybody should know about. I know everyone doesn't just yet, but they will eventually. Is the fact that since Reed Semiconductor has been founded, you've shipped millions of products and have had zero returns. And you were just talking about reliability and efficiency, but what can you tell us about Reed Semiconductor's emphasis on quality and reliability?
Thank you. Yeah, it's a great question. With that being said, right, because we are focused on AI data center application and probably like communication as well. This is the more it's not consumer products. They want extremely high reliability. So with that being said, we partnership with the best, the fab, right, and the team in the industry, partnership with them. And basically my team and myself, right, has been in this power management products for years. We know how challenging, how to address the availability from design, from technology, from qualification, from all this kind of step by step, right? It's like a design verification, design methodology, and qualification. All this come together to address the reliability for our products. So yeah, we are so glad and so happy, right? And all the effort paid back. So right now we have shipped you you know probably more than like 60, 70 million products and without any failure. This is it's proven, right? All the effort and hard work and has been paid off.
That's incredible. You got to hold on. You got to hold on to that secret sauce you got there. That's great. Um,
Thank you.
what do you envision Reed Semiconductor is going to look like in 3 to 5 years in terms of company size and products, and how do you plan to achieve that type of growth?
So the company will be organically grow. This is in my mind, but we still will be very focused on what we are capable. Basically, will be like AI data center, centric power management, but will be probably one-stop shop. So in other words, all the components around this ecosystem will have our solution. So that's our expertise and our basically what we can contribute the most into the industry. So I'm expecting in like coming like few years, we will be the team will be growing to around 500 people, and the revenue is loss of 500 million. I think that's the you know what we are going to do, and we are moving into this direction right now.
That's man, that's exciting. That's for sure.
Thank
Um,
you.
and part of that growth obviously is achieving success. And positive responses to the market. Can you tell us about the most exciting response you've received from the market thus far, or if there's like a specific success story you can share about a customer implementing your technology?
Yeah, so yes, I think the industry always like some innovation, like some can really address their challenges right now, right? So because of our solution, as I said, we are very focused, and we can bring something leading performance in the industry. That's the reason, for example, right now, like 48 volt is pretty hot and kind of very widely adopted in the industry. But from 48 down to the processor power, this is something still a lot of innovation, lots of uh, investigation right here. What's the best approach, right? So from 48 to 12, to the processor power, or from 40 to 6 volt to the processor power, or single stage, right? From 48 directly to sub 1 volt output, different approach, different technologies, I think this give a great opportunity for all the power engineering team and the society to innovate, to bring and contribute their ideas, innovations, genius, to change the world. For our side, we have basically established or developed product and technology can address, like 48 to 12 and 12 to the processor power, sub 1 volt. We also developed 48 to 6 and 6 down the road, right, to the processor power. We have seen like a big improvement from 48 to 6 and 6 to the processor power, save like 20 to 30% power loss. That's huge from the power loss reduction and thermal performance improvement. So with that being said, we will provide the weapon or system for any customer uh, to can tell, can see, can accomplish their goal, right, to reduce the power consumption, make the world greener, even with increased computing capability. So we are so happy we can contribute and help the industry to do that, help customers to do that, and lots of customers start to recognize that. And with high reliability record we have accomplished so far with focused this technology innovation. I really appreciate partnership give us this opportunity and embrace our solution, adopt our solution. Again, this is has to go through the partnership and collaboration. But I do appreciate, the lots of bigger names, big customers, start to adopt our solution. Yeah, it's a lot of fun and a lot of exciting momentum as well.
Oh, that's great. Yeah, I love the momentum that's brought on to you guys. It's very, very cool. And obviously momentum doesn't happen without innovation, and innovation often requires taking some pretty substantial risks. And as a leader, how do you strike the balance between fostering a culture of innovation and making responsible investments in areas like people and R&D?
This is a great question. So in my mind, right? So actually, to be honest, I have been in this industry for like more than 20 years, right? I know this is kind of high-end application, right? You don't want see your data lost and the data center down. So with that being said, I'm a conservative guy. So with that being said, how to mitigate the risk is definitely the number one priority in our mind. So yes, we want innovation, but you will want keep in mind how to reduce their product development risk and the market risk and also customer the risk as well. So with that being said, we develop some like a common industry like a second source part, pin to pin, bomb to bomb. Basically, you prove your team, prove your technology, right? Your solution is competitive and you have a lot of expertise. You can compete. Make the world better. At the same time, if your innovation is around that, it's like either baby step or have some common footprint. You put some innovation inside, but bring more value, higher performance to the customer. That the customer will be much easier to adopt your solution, accept your solution as well. So yes, innovation sometimes you cannot tell from outside. Um, for example, like availability and efficiency, right? You just simply um, like a compared performance outside of the packaging, but inside you can have a lot of innovation inside. And in addition to that, right, you do have some probably like breakthrough technology. You do need some innovation right there as well. How to leverage your expertise, how do the qualification, have enough margin, enough qualification, and work with end customers to mitigate the risk. This is something we can work with our partners to address that as well. So in other words, we do have two approaches. One is more like uh, traditional lower risk, a low risk, right? Basically, come out some second source part, pin to pin, bomb to bomb, but at the same time, like a baby step with a smaller change, but you have a bring enough and a lot of innovation, lots of breakthrough, and bring more reliability, higher reliability, better efficiency, better performance to the customer. I think customer will be more than happy to see that.
Wow. Yeah, no, there's definitely a lot of moving parts and trying to strike that balance, and it's kind of it's a never-ending quest. I know that.
Exactly, exactly.
And to another challenge and shifting gears a little bit to discussing talent and what qualities that you personally look for in engineers and how you actually know when you've identified somebody who can help the company succeed.
Yeah, it's a great question. So I always said, the power management, power electronics, right? It's hardware based, to provide the power for the processors. Sometimes I was always joking, right? Hardware it means, it's a lot of hard work, right? Here, doesn't mean, the hard work does not need the hard work, but this is hardware. You do need like hands dirty. You need gain a lot of experience or first-hand experience and understanding for the power. So with that being said, I think you know, know the power, know the challenges, because the power is a power loss, magnetic control, thermal. It's a lot of background or experience come together. So with that being said, it's hard, to find the background, to suit, to have all this background. But at the same, once you have a passion, a love doing that, actually, you really like myself, right? I devote my whole career into this area. I still love it. I still have a lot of passion on it. So with that being said, so we love to have this kind of and peers, colleagues, new graduate have this, want to contribute to the industry. to make the world greener, have this power electronics background, or like to learn, like to contribute into this world, right? Because right now the AI and data center is very hot. It's very challenging already. We have seen the market requirement and the trend right here. So with that being said, some electric engineer like to devote himself and career in to contribute to the world to make the world greener. We are more than happy to provide offer a platform and arena for them to excel their capability and their expertise.
Very, very cool. Very cool. I mean, and the identification is half the battle, and then the other battle is actually, recruiting somebody to the team. I mean, what's one of the toughest challenges you've faced so far recruiting talent to Reed Semiconductor, and how are you working to overcome that?
Yeah, it's a pretty great question, right? So right now, I think the rate is relatively small. This is some customer, some like new graduate, some engineer, right, looking for like stable work, stable company. Probably there's some challenge for us. But on the other hand, um, I would like to see, right? It's a growing company, as you can see. A lot of things you need to learn. You can learn from the resemi. So with that being said, it will be the balance, right? For you learn something, prove yourself. In resemi, I think you have a more opportunity, to grow and learn from the resemi. But there's something, compared to some very established companies right now, actually they are, hiring, this background engineers, uh, you know, actually they have a lot of opening and, opportunity right there as well because AI, right, data center needed power. So they have it's also challenge for them as well for end applications. So that's the reason we are competing with them. We are like provide the solution, but end customer they want to solve the issue with our solution. So it's a depends upon, right? So if they want like stable like job, and that's the so basically we're competing with some very established and system companies, right, for the talent. So this challenge we are facing right now.
Okay. Yeah, and that's actually a very unique kind of approach there in terms of talking to somebody that may not need to leave their job, but you're talking to them about the benefits of joining Reed Semiconductor. It's solution based, it's green, and you're going to be able to come in and learn a lot of different things. Is kind of what I just heard. So that's
Yes, exactly,
that's that
exactly.
that sounds great. Yeah, very, very cool. Wenkai, how can someone get in touch with you if they want to discuss purchasing, a potential partnership, or might even be considering joining the company?
Thank you. Yeah, so I think they have a lot of way, right, to approach us through our website. So like send us some emails through the website contact information, and also like a LinkedIn, and also from our sales team. I think right now we do have some public uh, access, for the people, right, to submit their, like a resume and, contact our fair people, to reach out to us. And, I think that's pretty much, I think we have the website, 3w resemi.com. You can look at our website, our technology, and our products, and also they have a link how to access us as well.
Terrific. That's great. Great. Well, thank you, Wenkai, for joining us in our sweet C-suite spotlight series. It's been great having you here, and we here at SBT, we're very, very excited to see what's coming forward with Reed Semiconductor and your growth.
You're very welcome. Thank you, Jason, for having me here. So thank you very much.
Absolutely.